Quantum mechanics has a reputation for being extremely counterintuitive and mysterious, but it's also the best theory that we have of the world, and it allows us to make some incredibly precise predictions. So James, as a quantum scientist, can you explain to me what is quantum mechanics and what are some of its defining features?
Yeah, quantum mechanics is amazing. It describes absolutely everything in nature, from the electrons whizzing around in computer circuits to the warm glow of the sun. And when you get down to the microscopic level of atoms, molecules, photons, electrons, then some strange behaviors start to occur, which can only be described by quantum mechanics. So it says that everything that can happen, everything that's possible, depends on everything else that could be possible. This is called quantum superposition. So think of it like if you have a speaker in a room playing sound and it fills that room with sound. Quantum superposition says that a quantum particle fills space with waves of probability. You can imagine it like if I was waiting at a microscopic train station for a quantum particle to arrive, then quantum mechanics tells me how likely it is to arrive at platform 1 or platform 3, but never exactly where it will alight with certainty. To understand and to calculate where this particle will end up, I have to imagine that it's riding all of the trains in the network simultaneously in a quantum superposition. So that's how quantum mechanics describes nature.
What's your favorite weird thing that happens in quantum mechanics?
Oh, well, I love lasers, and you can use lasers to control atoms incredibly well. So you can get these big clouds of very, very cold atoms, and you can use lasers to put them in a quantum superposition. So you can make these clouds of atoms move in 2 different directions at the same time. Now, although atoms are really tiny, they weigh something, so they're sensitive to gravity. And if gravity is changing over space, then this superposition of atoms is sensitive to that. And quantum mechanics allows us to measure this change in gravity with incredible precision. So why might gravity change over space? Well, if I just have a pipe underground, that pipe has slightly different gravity to the Earth around it, so I can use quantum superposition to take photographs underground, which is amazing. Other quantum sensors allow you to detect tiny amounts of light for bioimaging. They can help you detect tiny little changes in the direction you're moving for self-driving cars, and they can even detect your brainwave for brain imaging.
And what's the biggest myth you'd like to dispel about quantum mechanics?
Well, I think because all of the strangest quantum mechanical effects only happen at the microscopic level, people think that all of the consequences of quantum mechanics are at that tiny, tiny scale. But these microscopic effects have macroscopic consequences that affect all of our lives. Without quantum mechanics, we can't understand how the sun bathes us in warm light rather than deadly heat, or why glass is transparent, or how chemical reactions work. We really need quantum mechanics to describe just about everything in nature.
Okay, so just to see if I've got this then. A key idea in quantum mechanics is this notion of superposition. So in the classical world, we're used to things being in a fixed, definite state. But in the quantum world, something like a quantum particle can be in a superposition of multiple states at once. And in order to know what happens to that particle, I need to consider all the possible things that could happen to it to actually be able to calculate something.
That's right, you've got it.